Hello, this is Mr. Justice, and I'm going to go through Population Math 1. This video is not meant to be watched from start to finish. You can kind of go forward, go back, push pause, find the question that you need help on, and then kind of go from there. All right, I'm going to go through them in order. Let's go through question 1. I'm not going to do the math on all of these on question 1 because you kind of start to get the point after the first one. Let's do country A. So let's see, we've got R is equal to CBR minus CDR over 10. And we divide it by 10 because these CBR numbers are out of 1,000. And so if we divide them by 10, they'll be out of 100, which allows us to turn that into a percentage. So let's see. Country A has a CBR of 12 and a CDR of 7. This is equal to 5 over 10. This is equal to 0.5%. So that's the growth rate R. To figure out the doubling time dt is equal to 70 divided by R, which is equal to 70 divided by 0.5. which is equal to, I'm going to need a calculator for this. Notice that I just dropped the percent sign, all right? I don't have to move the decimal point over anywhere for that with this formula. So let's see, 70 divided by 0.5 is equal to 140 years is the answer. Kind of makes sense. It's a low growth rate, and so it will take a long time for that population to double. Let's do question C, or country C rather. So this one, we know the growth rate, but we're missing CDR. So think about it, it's just algebra. We've got X, solve for X. So let's see, all right, I'm gonna use the same formula up here. So CBR of 22 minus my unknown CDR over 10 is equal to 1.3. This is country C, that was country A. All right, let's do this. I've got to get CDR by itself, and so I'll multiply both sides by 10. 22 minus CDR. All right, I've got to get CDR by itself, so I'm going to subtract 22 from both sides. Let's see, that's going to be 9 minus 9. So, right, if both sides are negative, then we can just make it positive, I suppose. So the CDR is now 9. Nine individuals die per 1,000, right, is the way that we can kind of read that. If we wanted to do the doubling time, it's the same problem as before. dt is equal to 70 divided by, 1.3. Notice that I'm not going to change the decimal point. I just drop the percent sign. What's 70 divided by 1.3? It looks like it's about 54 years. 54 years. All right. Let's see. Hey, notice that some of these here, like country D and country G, don't have doubling times. But if you look at it really carefully, you notice that the CDR, the deaths, are higher than the births. And so, right, if we have more outputs leaving than inputs, then we're going to have a decrease in population rate. It'll be negative number here, and negative growth rates don't like double in time, right? Because they'll decrease in size. Let's see, another one of these that would be difficult. Maybe this one, E. Let's try E, since we're given so little information here. So we're given the doubling time, and we're given the CDR. But we don't know CBR, and we don't know growth rate. All right, but could we figure out the growth rate, right? I mean, think about it. Doubling time is equal to 70 divided by R. Well, we can figure out R, couldn't we? Because we know doubling time. So 700 is equal to 70 divided by R. Let me show you a little trick. If you ever have an unknown in the denominator of one of your fractions in a problem like this, I don't know if you guys knew this, all you need to do is just switch these two numbers, and you get R is equal to 70 over 700, which is to say it is equal to 0.1%. Really slow growth rate, right? Kind of makes sense because the doubling time is so large, right? So think about this. Now that I know 0.1% is my R, I can now use that reverse engineer to solve for CBR. CBR minus, looks like it was 8 over 10 is equal to 0.1. And just now a matter of solving for CBR using similar math algebra that we did for country C, which I won't solve. Let's do 2. 2. All right. Do you need me to solve it? I'll suppose I'll solve it. Let's see. I'm going to get CBR by itself. Order of operations suggests I've got to multiply this times that first. So CBR minus 8 is equal to 1. CBR is equal to 9. Makes sense. CBR slightly more than CDR. All right, let's go to 2 now. All the rest of them, by the way, you can use to use math here that I did for countries A, C, and E. You will be able to now, I think, solve the rest of them in very similar manner. All right. 2 is, what is the crude birth rate of a country with a population size of 1,828,700 births? Let's do it. All right, so I know that CBR is equal to the births over the total pop. And then we're going to multiply that by 1,000. Remember, CBR, to standardize these numbers, we're going to multiply that fraction here by 1,000 to make it out of 1,000 individuals, right? All right, so we've got all the information here, so it's just a matter of solving the problem. 28,700 divided by 1,800,000 times 1,000. We need a calculator, don't we? Let's do it. Just typing stuff in. All right, look, that doesn't look like an answer. I want 8, multiply it by 1,000, and now it's about 15.9 individuals per 1,000. 15.9 people per 1,000. Question 3 is very similar to question 2. I'll do it. Let me kind of adjust my paper here. What am I doing? CDR is equal to deaths per total pop of a country. We'll multiply it by 1,000 to standardize that number. Let's see, question 3, 18,500 deaths per 1,800,000 individuals. Multiply that by 1,000. And we get 18,500 divided by... That doesn't look like a good answer. Hey, multiply it by 1,000 and we standardize the answer. 10.3 people per 1,000. All right, nice and simple. We're moving on to question 4. Given your answers to 2 and 3, oh, this is a good one. What is the population growth rate of the country? So let's do that. This is 4, right? I'm going to need the answers from last time. So I know that, what is it? R is equal to CBR minus CDR over 10, right? Both of these answers are out of 1,000. So if we divide them by 10, our number will be out of 100. That's a percent. All right, so let's plug in the answers from last time. It's 15.9 minus 10.3 over 10. We get, let's just see if I can do this in my head here. Isn't that 5.6? 5.6 divided by 10, which is to say 0.56%. All right, nice and simple. Let's keep moving with 5. Let's do it. How long will it take the population to double in size given the population growth rate you calculated it for? Oh, this one. Well, I know that doubling time is equal to 70 divided by 0.56, right? Just drop the percent sign. Bum, bam, bum, bam. 70 divided by 0.56, let's see what it is. There it is. 70 divided by 0.56 is equal to 125 years. 125 years. Very simple. All right, what's the next one? Number 6 looks like New Fremont had a birth rate of 22 per 1,000 in 2010 and a death rate of 7 per 1,000. Assuming no migration, calculate the population growth rate of the New Fremont area. Isn't that just right? R is equal to CBR minus CDR. I always write out the equation first because for me it's a lot easier to go through and just plug in the numbers that I know and then solve, right? And it's also kind of practice because the more I write this out on my paper and as I show my work, I'm kind of like getting it into my head a little bit more, right? All right, so what do we got? R is equal to 22 minus 7 over 10 is equal to 5 over 10 is equal to 0.5%. That was 6A. This is 6B. If the current population, this is just a question. 6B is just like, hey, doubling time. Takes a lot of words to just say simply, what's the doubling time? And I know that dt is equal to 70 divided by r. Doubling time is equal to 70 divided by 0.5. Excuse me, I've got like that throat. I don't know what's going on. All right, 70 divided by 0.5, I get 140 years. Doubles in 140 years. Moving on to 7. A, we'll say. 7A. All right. This one for 7, this takes into account migration. And, it's basically this, except that we're going to include increases. All right, so let's do it. So R is equal increases and decreases, right? Inputs and outputs. So we'll say CBR minus immigration per 1,000 minus CDR. Oh, I'm sorry, I made a mistake. Look at this. CBR plus the individuals that are coming in, right? Because those are the ones that input or increase population sizes. But then we'll subtract out the ones that decrease population size, and that's the deaths and emigration. Got to make sure I include that plus sign. My goodness, that could have been disastrous. Luckily, it wasn't. It's just a matter of now. Oh, and we'll divide it by 10, another opportunity for disaster, but that was quickly averted. Yes. Right? Remember, all of these are out of 1,000, so if we divide it out 10, divided by 10, now we get it out of 100, which is a percent, so our number here will be in percent. All right, so let's start plugging in some stuff here. I got 44 plus, looks like the immigrants with I is 12. We'll subtract out the outputs here, and that looks like that's 18 plus immigrants are 5. Oh my gosh, 5 divided by 10 is equal to, let's just do this, 56 minus, what is that, 23 minus, or divide, oh my gosh, you guys, divided by 10, let's keep going. 57, oh gosh, I used to be able to do this in my head, and I guess maybe I could. Looks like 33. Another disaster quickly averted. 33 divided by 10 is equal to 3.3, and since it's now out of 100, we can say, boom, put that percent sign there, it's good to go. Hey, 7B, yes, let's do this. It's a doubling time question. If I had to just guess, yes, how long will it take for the Central Fremont's population to double in size? Well, DT is equal to 70 divided by R. or 70 divided by 3.3. I dropped that percent sign. I don't need it here. 70 divided by 3.3 is equal to 21 years. 21 years, roughly, right? It's an estimate. We're moving on. That was 7A. Let's do 8. That was 7A and B. Let's do 8. In 2010, the crude birth rate in Lower Fremont was 25 and the death rate was 11. If the population was 15,000 in 2010 and the population growth rate remains constant, when will the population reach 30,000? This is a doubling time question. DT is equal to 70 divided by R. Now, what makes it difficult is because we've got to solve for R first, but it's basically the same math that we just did with question 7. It's the same thing. This time, though, we're not dealing with migration, and so we'll not have to include that in our equation. R is equal to CBR minus CDR over 10. It's equal to 25 minus 11 divided by 10. 14 divided by 10, 1.4%. Doubling time is equal to 70 divided by R is equal to 70 divided by 1.4. We drop the percent sign and you get, I think I can do this one in my head. Isn't it 50 years? So if the question, when will the population reach 30,000? So technically, if we're in 2010, 50 years later will be 2060. The year 2060 will be the correct answer. All right, number 9, A and B. I gave you guys a lot of questions. I'm going to keep going. 9A, all right. In 2020, East Fremont had a population of 10 million people, a CBR of 72, and a CDR of 22. What's the population growth? They're all the same question, aren't they? Right? You start to see a pattern here. So let's go over the 9A. What's the population growth rate? We're not dealing with migration, so we don't have to use that other formula. We just need to know CBR minus CDR divided by 10. Right? Think about these numbers are out of 1,000. And if we divide them by 10, they'll be out of 100, which is what a rate is. Helps us out a little bit. And hey, luckily this has given us information here, right? All we've got to do is plug in. Minus 22 divided by 10 is equal to 50 divided by 10 is equal to 5. And since it's out of 100, it's 5%. Oh, this becomes more difficult, though, in 9B. Look at this one. So this is how we make it more hard, I suppose. If the birth rates and death rates remain constant, in what year will the population be close to 40 million? Now, if you go back to the original question, it says 10 million. That's your cue here that we've gone from 10 million people, and we've doubled, right? We've doubled 2 times to 20 million. And then we've doubled 2 times to 40 million. So we've doubled twice, right? It's a doubling time question, but we've got to think about it a little bit, right? And apply it twice, assuming that population growth rate of 5% doesn't change. Let's figure out what the doubling time is first. Doubling time is equal to 70 divided by R, 70 divided by 5. This is equal to 14 years. For one doubling time, right? So think about this. To go from 10 million to 20 million, it'll be 14 years. And to go from 20 million to 40 million, assuming that population growth rate doesn't change, as long as it's 5% throughout, it'll take another 14 years for that population to double. And if you look at the question, it says, in what year will the population be close to 40 million people? So that's going to be 28 years. We add that to 2020, and that will be the year 2048, right? Right. Simple. So that was part B, I guess. Well, this would be. How's about 10? In 2010, the population of Fremontville was 6 million and growing at a rate of 1.4% per year. If the rate of population growth remains constant, in what year will the population reach 48 million? Another question, another doubling time question in disguise. So, right, think about it. We're going to go from 6 mil to doubling into time to 12 mil. And then we'll double that population, assuming 1.4% throughout. We'll go to 24 million. And we're going to double that again to 48 million. So now we're doing 3 doubling times, right? So let's figure out what doubling time is. Luckily, it's given us r already. dt is equal to 70 divided by r, which is to say 70 divided by 1.4. All I do is drop the percent sign. I don't have to move the decimal point. This is 50 years. So think about it. To go from 6 million to 12 million, it's going to be 50 years. To double again, it'll be another 50 years. To double again, it'll be another 150 years. Now think about this. In what year will the population reach 48 million, assuming no change in the growth rate of 1.4%? It will be 150 years later after 2010, so that's going to be 2160. The year 2160. Let's keep going. Let's look at number 11. What is the size of a population that starts at 500 and grows over 20 years at a constant growth rate of 6.2%? And I've given you a little hint that says use that exponential growth model in order to calculate this. And if you guys recall, the population after some time t is equal to the starting population times that irrational number e to the r times t. Now, we've been given all of the information except for n sub t. Right? We're looking for the population, size of the population after 25 years, and so we're going to solve for this one. Everything else we know, though. N sub O, the very start of it, is 500 individuals. We'll multiply it by the irrational number. It's like pi. It's just that it's equal to 2.718 with infinite number of decimal points afterwards, multiplied by the rate here. For this one, in this calculation, we will have to move that decimal point over. So 6.2% is actually 0.062. We'll multiply it by, 20 years here in our exponent. So now it's just an order of operations problem. I'm going to first deal with the exponents. So I'll find the product of that. That'll be my exponent to raise e to. And then I'll multiply that times 500, and that'll be my answer. So let's go ahead and do it. I am going to need my, not for function, but I'll need a scientific calculator because I can pull up e pretty easily. If you see it right here in my iPhone calculator. Although I don't want to do that. I want to do this first. So let's say 0.062 times 20. So that's equal to 1.24. All right, I'll just put that there to help me remember. All right, so now we're going to bring e to the 1.24th power. And my button to do that is x to the y here. So that's going to be my x to the next thing I type in will be the exponent 1.24. That's 3. So think about 500 times 3.456. We multiply that times 500, and the answer is going to be 1,700, and we'll go with 28. What's my people? So after 20 years at a growth rate of 1.24, rather 6.2% over 20 years, with a starting population of 500, we will have grown our population to 1,228 people roughly. It's an estimate. All right, we're coming down to the end game here. Take a look here, question number 12. How long will it take for a starting population of 1,500,000 people to grow to 5 million people given a population growth rate of 2.8%? I've solved this problem already, question number 12. Question number 12 is already on YouTube. In fact, here, I'm going to do this real quick. I'm going to, let's see, I'm going to copy this link address and give me 1 minute because I'm going to create for us a hyperlink. Okay, it's already on YouTube. So if you go to crjust.us/Q12, that will bring you to this YouTube video. Nice and simple. All right, let's do question 13. This one's going to probably take a little bit of time here. Assuming a constant population growth rate, which of these countries will have the largest population in 100 years? We can use the exponential growth rate formula or estimate it using the rule of 70. I think what I'm going to do is I'm going to use the exponential growth model here because I think that that's going to be the most accurate way to do this and probably the fastest, to be honest with you. And this will be good practice. So I'm going to do it for each one of these. Let's do, how about we say Madagascar first. So we're going to solve for n to the t for all of these, right? Our starting population is 15.2 million people. E to the 0.032 times 100. This is going to take forever. Look at this. I just realized that because I'm multiplying this by 100 years, it just moves the decimal point back to 3.2. Kind of makes sense, right? So that might actually be a little helpful to me. So I'm going to say, let's say e to the 3.2 times 15. There we go. So this one, oh wow, huge number. It's going to be, looks like, let's see, 1, 2, 3, 4, 5, 7, 8. How about we say 3.8 times 10 to the 8th people, more or less. That's for Madagascar. Let's go to the next one, Colombia. I'm just going to start plugging this in because it's pretty much the same formula, right? Remembering that since we're multiplying by 100 years, the growth rate of 2.1 will be the exponent 2.12. That makes sense. All right, this is equal to 38 million times 2.718 to the 2.1. Remember, it was 0.021 times 100 gets me the answer pretty quick. All right, so e to the 2.1 times, what was it, 38 million people? Yeah, there we go, is equal to 3.1 times 10 to the 8th individuals, people. All right, next one down, Sudan. Sudan is, let's start plugging in numbers. Let's see, 28 million people times e to the, well, 0.03 times 100 years is 3. Okay, this is a little faster than I thought using this. This formula here, huh? To the 3rd, oh wow, big number there, times, pretty big number as well. I think we might have our winner. We'll see though. Yeah, huge, right? Look at that. Is equal to 5.8 times 10 to the 8th people. Okay, nice. All right, France. France is, ooh, that's not a very high growth rate, is it? So what we're going to do, that's a lot of people though. 58.4 million people times the irrational number e times 0.003 times 100 years is 0.03. 3. All right. Ooh, I feel like this is going to be not very big. Let's take a look, though. Come on. Come on. Come on, calculator. Oh, gosh. Isn't this great? Just love stuff when it works. All right. I'm getting ahead of myself. Let me do this. E to the 0.3 times 58,400,000 is equal to 7.8 times 10 to the 7th people. Right, so small compared to the other ones. I think Sudan might be it. Let's see the Ivory Coast. Yeah, it's got to be 14,700,000 times E to the RT, which will be 3.5. All right, let's do E to the 3.5 is equal to that times 14,700,000. This is equal to, did I do that right? Yeah. Okay, this is equal to 4.8 times 10 to the 8th people. There you go. So the answer is, who will have the highest population after 100 years, given all of that information? The answer is going to be Sudan with 5.8 times 10 to the 8th people. All right, there you go. That's how to do all of the problems on questions 1 through 13 on that handout.